Hi, my name is Yunming, and today I'll give a short demo for GraphIt, a domain-specific language for writing high-performance graph applications. This is joint work with many collaborators at MIT and Adobe Research. Graph applications are everywhere these days, and achieving high performance is critical for them because many of the graphs are very large, and the applications often have a strict latency requirement. However, writing high-performance graph applications remains a hard problem. Here we show a naive implementation of the PageRank algorithm that ranks the nodes based on their importance in the topological structure. A parallel and cache NUMA optimized implementation is 23 times faster than the naive implementation on a 24-core machine, but it is much harder to write it correctly. It is also extremely difficult for programmers to experiment with different combinations of optimization strategies. GraphIt tackles this problem by decoupling the algorithm specification from optimization strategies. It has an algorithm language that specifies what to compute, and a separate sketching language to specify optimization strategies. It offers an easy-to-use interface while being powerful enough to beat hand-optimized graph frameworks by up to 4.8 times.
Now we show how to configure PageRank with different schedules in GraphIt. Here is a GraphIt implementation of PageRank. Notice that in this case no schedule is specified, so the program will run serially using the default schedule. We use the GraphIt compiler to compile the GraphIt file into a C++ file and subsequently compile it with the C++ compiler. It takes 189 seconds to run with the default schedule. Next, we go back to the GraphIt file to optimize its performance with some schedules. We can use a push-based schedule to execute the program by specifying configure apply direction S1 sparse push. S1 here denotes the edge set operator in the algorithm. On top of that, we can use the configure apply parallelization API to apply work-stealing based vertex parallelism to the edge set operator. We compile the updated graph file and the generated C++ file, and then run it on the 24-core server. Now the PageRank algorithm takes 36.9 seconds, achieving 5 times speedup. Instead of doing a push-based schedule, we can actually use a pull-based schedule to execute the PageRank, removing the overheads from using atomics. All we need to do is modifying the argument of configure apply direction from sparse push to dense pull. We again compile the updated GraphIt file and the generated C++ file and run it on the server. This will get us down to 15.34 seconds. Now we show you how to apply cache optimization on top of the optimizations shown earlier. We simply use the configure apply numums SSG API to partition the input graph into 12 segments. We compile the GraphIt and generated C++ file again and run it on the 24-core server. Now the running time is down to 9.17 seconds, achieving more than 20 times speedup over the default schedule. That concludes our demo, and thank you for your time.